Welcome to Math Mini Lessons. This is Sarah, and in today's lesson, you're going to learn how to apply rate and y-intercepts in real-world scenarios or just word problems. Here are the 3 things your teacher is going to look for by the end of this lesson. They want to know that you can identify the rate of change or the slope from a graph or a table using mathematically sound strategies. They also want to see that you can explain what the slope means, and finally that you can compare functions in different ways to figure out which one has the greatest rate of change or slope. Take 1 minute to think about this, and we're going to get started with our first example. Let's start with our very first problem. Each photographer charges a one-time equipment fee and an hourly rate. Which photographer charges more per hour and by how much? So in other words, who charges more per hour, or which one has the greater rate of change per hour? So here are facts. Well, the first one, honestly, there are just a ton of facts on that graph. We can choose any point to figure out how much over a certain number of hours is charged. And for B, we have 2 specific data points. We know he charges $105 for 3 hours and $145 for 5 hours. So here is my plan. We're going to use coordinates from the table and the graph to find the rate of change. So again, we're going to take some of that data and we're going to put it into our rate of change formula so we can figure out what the rate of change is. And once we have that, we can compare the rate of change to figure out which is larger. That's going to be our plan. As long as we have it as a unit rate, we'll know who charges more per hour, and then we can subtract to figure out by how much more per hour. Hit pause so you can jot this down into your notes. Okay, let's put this plan to action. We're going to find the rate of change or the slope on the graph first, and then we'll do it on the table using our change in y over change in x. So let's start with our graph first. I'm going to look and identify 2 points that are very easy to see and identify. So I like this one here, which is 0.25. And I'm going to choose this point over here, which is 175. So we're going to use those. And I'm using that to create my triangle, which is going to tell me again, going up and down first, change in y and change in x. So my change in y, it's going from 25 to 175, so that's a difference of 150. It's going up 150, so that's positive. And my change in x is going from 0 to 5. So my change in x is just 5. All right, so for my graph, my slope is 150 over 5, $150 over 5 hours. And I'm going to simplify that into 30. So 15 divided by 5 is 3, so 150 divided by 5 is 30. So $30 per 1 hour. There's my slope. Now let's look at the second example, which is the photographer on the graph. And again, I'm looking for my change in y over my change in x. And I'm going to use a formula, y2 minus y1. So how my y's change over x2 minus x1, the difference in my x's. So starting here, hours are going to be, here's my x, this is my y. I want the price to be first. So 145 minus 105 over 5 minus 3. All right, let's simplify that out. 145 minus 105 is 40. So 40 over 2. So $40 for every 2 hours, which we could simplify this to $20 for every 1 hour. All right, so looking at those 2 rates, which one is charging more and by how much? We can see it here. Photographer A charges more. He's charging $10 more per hour. So let's write this down. Which photographer charges more? Photographer A charges more than photographer they charge $10 more per hour than photographer B. And there you have it. There's my big takeaways. I'm just identifying the slope on a graph, using my triangle to help me find change in y over change in x, and finding the slope, the rate of change on a table, again using change in y over change in x. Hit pause and jot this down in your notes. Take a moment to stop and read the problem for yourself. Awesome. Now, Johnny and Selena want to rent a tent with the best possible rate. And since they are the buyers, that means they want the lower cost. And they have their two options here. And they are looking to rent for 7 hours. Now, with the first company, there is a one-time fee of $100 plus an additional charge of $60 per hour. So we have our constants. And we have a rate change. And in the second one, we have Party on Tents charges a different amount for the one-time fee. So we don't know their constant fee, that's unknown. So I'm a little question mark there, but we can figure out the additional cost per hour. We're going to do both of those things by looking at a rate. So two different approaches coming in. And the first one, I have the information, but I don't have the cost. And the second one, I have the table, but I don't have the initial information. So let's start with the first one. And we know that there is an initial fee of $100. So first, how would I express this? I know that there is a fee of $60 per hour plus $100 no matter what. So in the beginning, if there are 0 hours, so 60 times 0 plus 100, well, I know this is going to be 0 plus 100, so this is only going to be 100. All right, so there is no additional one. So that's it. As soon as the clock starts and that full hour hasn't even gone, you pay $100. So now an hour goes by and we're going to add $60 to that. That's all I'm adding. That's our rate for 1 hour. And then in our second hour, we're going to add another 60. And we're going to add another 60 for the third hour. And so you can see what is happening here. So when you were younger, you remember you would just continue to add on this constant difference. So let's fill in the rest here. And there you go. And all I did was just add the additional rate, $60 an hour, but I could have just evaluated with our equation. So let's do our 7th hour. And I'm going to evaluate it. 60 times 7 plus 100. That's 420 plus 100 or $520. So again, I'm doing this in both ways on purpose to show you that I could just evaluate to find the cost at any hour, or I can just continue skip counting until I got to the 7th hour. Either one will work. Here we go. So I know my cost for 7 hours with LLC Party Tents. With the second one, I don't know the rates, and I do want to write an equation here. So let's look at what we see and what we notice. And since I don't know what happens at 0, I'm going to look for the differences between here and here. We're going to look for the constant difference. And from here to here, there is a difference, an increase of $50. And here between $250 and $300, $50. So I do see there is a constant difference. It's not changing. So that is my rate. So 50x plus, let's figure out what our initial cost would be. And for that, I'm just going to go backwards. Like, what if we went backwards by 50? So from 200, if I went back by 50, I would have been at 150. So that's my initial cost. And there's my equation. So if I want the 7th one, again, 50 times 7 plus 150, 350 plus 150 is 500. Or I could have just added 50. So given these numbers, this is going to be better for us. This is the better rate. And why? Because paying $500 is better for me as a buyer than paying $520. So hit pause and jot this down into your notes. All right, and before we go on for today, even though we have it at this hour, this is the better rate. And at each time you can see, was that always true? Like at hour 1, actually, it would, if they had only rented for 1 hour, it would have been better to rent from this company over here. And the same thing with hour 2, and I would just be comparing costs. This is the better rate. In hour 3, this is the better rate. And then you can start to see, where does that change? It starts to change here at hour 5, where it's the exact same cost. So up until hour 5, I would have gone with this company. At hour 5, it doesn't matter which company. But now that we're in hour 6, this is costing more. And so that's something to just keep in mind, that when we're thinking about systems of equations with different rates, it can change. The best price may not consistently be the same. It may change based on the hour. So that's it for today, Math Marvels. I hope you actually use a lot of this information as you start doing your own comparisons as a buyer, as a shopper, and you can use the same mathematics. I will see you in the next lesson. Be well.